Welcome to the WION podcast, where we explore fascinating stories and ideas from various fields. https www.wionews.com. Photos: Iran, war. Why Russia S-300 couldn't survive. Israel S Blue Sparrow missile 17772940151865. In this episode, we uncover the hidden flaw that allowed Israel's Blue Sparrow missile to defeat the Russian-made S-300 system. A deadly vertical blind spot that turns one of the world's most feared air defenses completely blind from above. The heart of Iran's Russian-supplied S-300 PMU-2 battery is the 30N6E2 engagement radar, NATO reporting name, Tombstone. This is a massive phased array radar designed during the Cold War to track and destroy American F-16s, B-52 bombers, and low-flying cruise missiles. Because of this, the Tombstone is mechanically designed to sweep the horizon. It looks outward in a wide arc, searching for threats flying parallel to the Earth. Because the S-300 is designed to look out, it struggles to look straight up. Every ground-based planar array radar system suffers from a physical limitation known as the zenith blind spot, a massive cone of dead space directly above the radar array. If a weapon can somehow position itself directly over the S-300, the system is functionally blind. This is exactly the flaw the Israeli Blue Sparrow air-launched ballistic missile, or ALBM, was built to exploit. Dropped from an F-15 fighter jet hundreds of miles away, the Blue Sparrow uses a quasi-ballistic trajectory to shoot out of the atmosphere. Once it aligns with the target, the re-entry vehicle detaches and plunges completely vertically. It doesn't fly at the S-300. It drops straight down the cone of silence, entirely bypassing the Tombstone's scanning geometry. Even if Iran's wider early warning radars detect the initial launch from Iraqi or Syrian airspace, the engagement window is practically non-existent. The Blue Sparrow drops from the stratosphere at hypersonic speeds exceeding Mach 5. By the time the re-entry vehicle enters the S-300's theoretical engagement envelope, the Russian computers have mere seconds to calculate a firing solution, a mathematical impossibility for a system built in the 1990s. Let's assume the impossible. The S-300 detects the Blue Sparrow and manages to fire an interceptor missile. Intercepting a weapon dropping vertically at Mach 5 doesn't vaporize it. Hitting a solid metal 1900 kilograms penetrator at those speeds simply breaks it into massive hypersonic chunks of shrapnel. Because the weapon is dropping straight down, all that kinetic energy and debris still impacts the radar base, destroying it anyway. This catastrophic mechanical failure isn't theoretical. Israel already proved it in combat. On April 19, 2024, Israel fired a Sparrow variant ALBM at the 8th Shikari Air Base in Isfahan, Iran, which was guarding the Natanz nuclear site. The missile completely bypassed the early warning nets and obliterated the S-300's Tombstone radar right off its chassis. The recent decapitation strikes in Tehran simply repeated this proven tactic on a wider scale. Following the destruction of their S-300s, Iranian state media heavily touted their indigenous Bavar 373 air defense system, claiming it is an S-400 killer. However, defense analysts note that the Bavar 373 utilizes the exact same planar array radar architecture as the Russian systems it was reverse-engineered from. It shares the exact same vertical blind spot, meaning Tehran currently possesses zero defense against Israel's missiles from space. Thanks for tuning into this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.